You know, some of the most powerful technologies in the world are ones you've never even heard of. They're the silent workhorses, the invisible engines running in the background, quietly making sure everything just works. Today, we're going to pull back the curtain on one of the biggest ones. Okay, just try to wrap your head around this for a second. We're talking about a single piece of technology with two jobs. Job number one, track every single part for NASA's space shuttle program. Job number two, manage the incredibly sensitive data for the entire U.S. Internal Revenue Service. I mean, the stakes don't get much higher than that. A single error could be absolutely catastrophic. So that's the big question, isn't it? If this thing was so critical, so fundamental to space exploration and our country's finances, why isn't it a household name like Oracle or Microsoft? Well, that is the mystery we're going to solve today. All right, let's give this mystery a name. It was called System 2000. And for a really important time in our history, it was the invisible data backbone for the US government. Its story takes us on a trip back in time to a completely different era of computing, long before the databases we all know and use today. So, picture this. It's the 1970s. System 2000 comes onto the scene from a company called MRI Systems Corporation. And we are not talking about software you could run on a PC. No way. This was a beast, an absolute monster built for those gigantic IBM mainframes. Its entire philosophy was built on three things: insane speed, rock-solid security, and the ability to handle just massive data sets. So, what was the secret sauce? What made System 2000 so special? Well, to really get it, you have to kind of rewire your brain a little. It thought about data in a fundamentally different way than we do now. It required a total mental shift. You had to stop thinking in tables and start thinking in trees. System 2000 was what's called a hierarchical database. The easiest way to picture this is to just think about the file system on your computer, right? You've got a main folder, that's the parent, and inside that folder, you've got more folders and files, those are the children. Data in System 2000 was organized in exactly that kind of nested, tree-like way. And here is the crucial difference. With that tree structure, if you knew the exact path to your data, man, it was lightning fast. It's just like navigating directly to a specific folder. Modern databases, the SQL kind, they work differently. They organize data in tables that look kind of like spreadsheets, and you can join them together in all sorts of flexible ways. So one is built for pure speed down a known path. The other is built for flexibility when you need to ask new questions. So, with this rigid but incredibly powerful structure, where did System 2000 really shine? Well, it found its home in places where data paths were predictable and speed was absolutely, positively non-negotiable. And I mean, just look at this list of users. It's a who's who of critical American infrastructure. The IRS, the Department of Defense, and of course, NASA. These are organizations that could not afford slow queries or corrupted data. They needed a system that was, above all else, completely and utterly trustworthy. And this right here, this is an incredible personal look at the system's impact. This wasn't some abstract piece of tech. Real engineers were depending on it every single day to manage the thousands upon thousands of components for the space shuttle. Just try to imagine the sheer complexity of that inventory. And that's really the heart of it. System 2000 was never about flashy interfaces or cool reports. It was a serious tool for serious work. You can think of it like a digital quartermaster, making sure every part, every record, and every piece of data was precisely where it needed to be, right when it needed to be there. Okay, so how did developers actually use this thing? It wasn't as simple as writing a quick line of code. No. Working with System 2000 was a true act of programming. To use it, you had to speak its language, and that was a specialized proprietary language called S2K. And yeah, it had some things in common with modern SQL, but it was fundamentally designed for just one thing: navigating those hierarchical, tree-like data paths we just talked about. This thing was absolutely a tool built for its time. It integrated deeply with the big programming languages of the era, COBOL and Fortran. It was designed for what's called batch processing, running these huge, scheduled jobs, and had incredible transaction controls to guarantee data integrity. Every single feature was perfectly tuned for the mainframe world. This quote just gets to the absolute heart of the matter. You didn't just ask System 2000 a question. You wrote a program that instructed it, step by step, how to walk through the data tree to find the answer. It demanded more from developers, for sure, but the payoff was immense power and precise control. So where does that leave System 2000 today? Well, you won't find it running in modern data centers, but its legacy is absolutely undeniable. It represents a critical chapter in the story of how we learn to manage information. This timeline shows you exactly where it fits in history. It was a dominant force in the 1970s, paving the way before the relational model in SQL totally took over in the 80s. But what's really fascinating is that its structured, tree-based approach, while it actually foreshadowed a lot of the ideas that would pop back up decades later in the NoSQL movement. And maybe this is its most important legacy. For an entire generation of engineers building our nation's most critical systems, System 2000 shaped how they thought about data. It wasn't about rows and columns. It was about parents, children, and pathways, a completely different mental model for solving problems. And that is the perfect way to think about it. It's so easy to dismiss old technology as just legacy code. But a system that helped put the space shuttle into orbit and kept critical government services online, it deserves a much better title than that. It is truly legendary. And this brings us to a final thought. System 2000 is just one example of this hidden world of technology. It really makes you wonder, how many other unseen legendary systems are out there right now, quietly keeping the lights on, the planes in the air, and our world running?